Hey Superstar students, it's Dr. Conklin here to do a lesson on some trigonometry. We're on page 35, 35. And today we're going to do sort of a similar idea to what Mr. Fields covered yesterday, but a little bit different in that if you look at this page 35, you notice there's no pictures. Boo! However, this is when you guys can get your creative side out. We're going to be doing a little drawing today, okay? So we're going to start off with A. Our directions say to create a diagram, label the diagram by putting X for the missing variable, okay? And I think we're going to round all our answers to the tenths, just so we have that written somewhere. All right, so our first problem says a young boy lets out 30 feet of string on his kite. If the angle of elevation, okay, so remember this word elevation can be a little tricky. Elevation, if you think about it, you're going up, right? So the angle of elevation from the boy to his kite is 27 degrees. How high is the kite? So what I'm going to do to help me is I'm going to put a little X here, because that's what we want to find. Whenever you have that question word, how high is the kite? That's what our variable is. Now notice also, my loves, that I have highlighted on page 35 the two numbers we're going to need to put in our diagram. Okay, so let's start. We have a kite, so he has some string. So here's our little friend. Okay, his name is Justin Bieber. I don't know if you guys know him. He's a nice friend. I've met him a couple times. Okay, and he has 30 feet of string let loose. So again, and I'm going to make sure to put my feet with it so I don't lose it. If the angle of elevation, okay, so now, if he's right here, his angle of elevation is sort of from his sight going up. We don't know, or no, we do know that. That is 27 degrees. So 27 degrees, and you see how if we continue this on, we have a little right triangle here. Okay, so basically, whenever you make these pictures, you want to make sure that your picture has that right triangle in there that we can trace. Okay, how high is the kite? So how high is, and I didn't even draw the kite on. Oh my goodness. I'm so sad at my drawing skills. Oh, that's actually one of my better kites, just saying. It'll only take me 14 years to get down this drawing kites. This is where I'm going to put the X. Okay, so now this really isn't anything different than what we've already done. Sorry, Justin, I gotta get rid of your name. Because once we have the picture, you guys are awesome at this part. Our quizzes were so good. All right, we're gonna start with H, O, and A. So here's my angle, and we already have Justin standing there. Our H is 30, and our O is X. So as soon as we see these real world problems, remember our friend, SOHCAHTOA. Okay, so which one are we going to use? We have O and A, you guys guessed it, T. So tangent of 27 equals, by O and my A, X over 30. Oh wait, hold on, back it up. I did this wrong. I'll either put a cut in or put a note in. I clearly am not very good at writing H's because I thought that was an A. This is an H. So what should I be using, my friends? I should be using so. Okay, and I don't like that color. So sine of 27 equals X over 30. Now let's make sure our calculator is in the right mode as always. So I'm going to hit mode. Oh, it was, good thing I checked, right? It was in radian. So go back, click degree, okay? And then, now these are across from each other. So when I all I have to do is multiply here. X equals 30 times sine of 27. $13.6. And you think you're done here, but guess what? On the regions, you are about to lose a point, my friends. What are we going to do if we lose the point here? What are we forgetting? Feet, right? It wants to know how high we are. So that's your answer. Now, does that answer make sense? So again, we've been talking about that. Look at your hypotenuse. Our hypotenuse is 30 feet, the length of the string. Would we expect that this length over here, this X, the opposite side in green, would we expect that to be less than 30? Yeah, because the hypotenuse should be the longest. Okay, so let's read this one, and then I'm going to have you guys try your picture on your own before I show it to you. Oh dear. Sorry guys, sometimes the iPad, it's like a little, like freaks out a little bit. Oh, wrong way. Sorry. Here we go. Okay, so we're still on page 35. A 20-foot ladder, so I'm highlighting that 20, leans against a wall so that it can reach a window 18 feet off the ground. Now here's another hint. You're going to start to see patterns with these, my friends. If you have information, we have 2 side lengths. Guess what they're probably going to ask for? What is the angle formed at the foot of the ladder? So I'm going to put a little X there. We want to find our angle. Now, if you want to impress your friends, you could also use, remember what does that stand for? The little circle through it. It's a Greek letter. That stands for what? Oh, no, you saw my picture. Theta. Okay? So I want you to try to do this picture on your own. You know, you should be filling in your notes because I'm going to have you hand it in to check it. Try to do this picture on your own, and then you can check my picture, okay? Okay. Oh, and I actually hadn't put X in yet. So here, I'm going to use theta because I want to be fancy today. So check your work. Make sure you have your hypotenuse is actually the ladder, and this 18 feet down here, this is how far the ladder is from the wall. Okay, so now let's go through. Again, this is all like building on each other. We're going to do our H, our O, and our A. Our H is 20 feet. Our A is 18 feet. So looking back at SOHCAHTOA, we have our C and our A. So we're going to use cosine. Cosine of theta equals A over H. 18 over 20. Now, I know you guys know this. How do we get this theta by itself? We need to get rid of that cosine. The only way to do that is the inverse on both sides. So these are going to cancel. Theta, or our angle, is the inverse of theta, 18 divided by 20. So second cosine, 18 divided by 30. Oh wait, was it 30 or 20? See, always good to check, my friends. Delete 20. And then enter. So it looks like 25.8. And again, ask yourself, 25.8 degrees. Does it make sense that this acute angle is 25.8 degrees? I know in class we talked a little bit about what would be some wrong answers to put here. Degrees. You know, somebody put in the chat 555. Oh yeah, anything bigger than 180 is not good. Anything bigger than 90 is not good. Even 90 isn't good because 90 and 90, right? No negative angles. You can't have a 0. Okay? Let's go down and do maybe one more together. If you guys could look at F. Okay, so we have a man in a lighthouse. I don't like how it just says a man. Let's make this into a girl. Miss Falla is in a lighthouse. Good for Miss Falla. I hope she's somewhere like nice and warm, maybe like Mediterranean islands of Greece or somewhere. Miss Falla is in a lighthouse that is 30 feet tall. She spots a ship at sea at the angle of depression of 10 degrees. Oh boy, depression, what? How far is the ship from the base of the lighthouse? Okay, so here's my attempt at drawing a lighthouse. This might be one of my better lighthouses. Really? Yeah, that's a lighthouse. Okay, and then where's Miss Falla? Let's put her in. All right, so maybe she's like right here. That looks just like her. Miss V. Okay. So she's in a lighthouse tower that is 30 feet. So let's just say that this guy is 30 feet. Okay. She spots a ship at sea. Oh boy, this is going to be the good, interesting part. By ship, I mean sailboat, because that's what I can draw. That is at an angle of depression of 10 degrees. Oh dear. So what does that mean when we talk about angle of depression? Well, I'm going to start by doing Miss Falla's sight line. So do you guys see? This is sort of her you know what, let me pick a different color. This is her sight line right here. Now she sees the ship, right? Angle of depression means we're actually not going to draw a triangle up. We're going to draw a triangle that's going almost down, right? This angle is what she sees from here to here. That's our angle of depression. She's looking down at the boat, right? Okay. Yep, right there, guys. Sorry, I had to play around with it. So if you look here, let's put in the numbers we know. We know this is 30 feet. We already did that. We know this is 10 degrees. Okay, so from, and this is where it can be a little tricky. 30 feet, I'm going to extend this out. If I look here, right, this also has to be 30 feet. These two pieces here. Everyone with me? 30 feet, doesn't matter which way she's going. And then this has to be our right angle. So what we're going to do, and they want us to find the length from the ship. So if I look here, here's my X, here's my X. Remember, those have to be the same. It's almost like we've formed a nice little rectangle here, which will cover more. So let me get rid of this for a second. So let me highlight the triangle that we're going to focus our eyes on. This triangle right here. Okay, so this is the hardest part. I have to be honest, we haven't seen too many problems on the regions where they've asked you to do angle of depression, but we do want to just go over it so it's not a shock, my loves. Oh, I need to pick a different color. I keep pretty purple. Okay, so here's our angle. Miss Val is looking down. We have 30 feet. That's her opposite, and we want to find the adjacent. Remember, what we really want to find is this X down here, but if we know this guy in the top, we know this guy in the bottom. So let's do our O and our A. If I remember back, that's going to be TOA, right? So tangent of 10 equals 30 over X. Okay, then this is even trickier because we got to take these two and switcheroo them so we can divide out. So, oops, I already forgot what I was doing. X equals 30 over tangent of X. Now, what's this, or tangent of 10, sorry guys. Now this is where we're really going to want to use that strategy of checking our work as we go. So I'm going to take my 30 divided by tangent of 10. Oops, I don't want that. Hold on, I get too many parentheses in there. 170.1. Let's think about it. Oops, 170.1 feet. Does that answer make sense, my friends? Does it seem like you could see a ship 170 feet away? I mean, I think that seems reasonable. What would be some answers that would not work for this length, the distance between Miss Vala's lighthouse and the ship? Some answers that wouldn't work would obviously be anything negative. This number's 30, so I'm thinking it should be around 30 or more. And it sort of makes sense that if you're looking far away, that the ship distance is going to be 170 feet. Okay, we are going to do more problems like this as we move on to our project tomorrow. But just to give you guys a couple, please remember as we move ahead, anytime you have a trig problem without a picture, you need to draw one. Okay, hope you guys have a great day, and we will talk soon. Bye.